Ever since we first discovered exoplanets, planets outside our solar system, we have tried to find evidence that would show the presence of life on those planets. But given the distance to those planets, and our current technology which limits exploring even neighboring Mars only with robots, scientists need to think of novel methods to carry out their search for alien life. An effective method is to look for biosignatures, or indirect evidence of biological activity, such as the presence of certain chemicals in a planet's atmosphere, provided the planet already meets other criteria for sustaining life as we know it. These criteria include things like the presence of liquid water, surface temperature and distance from the host star. Since life, as we know it today, depends on the presence of oxygen in Earth's atmosphere, scientists have usually looked for chemical signatures of plentiful oxygen in the atmospheres of other planets as a proxy for the potential existence of life on them. But researchers from University of Washington UW proposed another method, in a study published Wednesday, which they said may be more promising than just looking for oxygen. This idea of looking for atmospheric oxygen as a biosignature has been around for a long time. And it's a good strategy. It's very hard to make much oxygen without life. But we don't want to put all our eggs in one basket. Even if life is common in the cosmos, we have no idea if it will be a life that makes oxygen. The biochemistry of oxygen production is very complex and could be quite rare, Joshua Chrysansontartan, a doctoral student at the university and corresponding author of the study, said in a statement. That makes a lot of sense, given the fact that even life on Earth existed for billions of years without oxygen. Life existed on our planet as long back as 3.5 billion years ago, and the microorganisms that were the only life forms on Earth for the following 1.52 billion years survived on sulfur and methane, not oxygen. First relatively complex life forms appeared 2.116 billion years ago, but the first large plants and animals only showed up about 800 million years ago, an evolutionary step often associated with rise in atmospheric oxygen. But a recent study showed that it was only between 540 and 420 million years ago that oxygen in the atmosphere rose to about half of today's 21%. The UW researchers looked at the history of life on Earth and identified gases other than oxygen which, in a specific combination, would be evidence of life on another planet. Future telescopes like the James Webb Space Telescope will observe the atmospheres of distant planets to seek evidence of life. Earth top left has several gases in its atmosphere that reveal the presence of life, primarily oxygen and ozone. The new study finds that for the early Earth bottom left, the combination of abundant methane and carbon dioxide would provide an alternative sign of life. Photo NASA Wikimedia Commons Joshua Chrysansontartan. We need to look for fairly abundant methane and carbon dioxide in a world that has liquid water at its surface and find an absence of carbon monoxide. Our study shows that this combination would be a compelling sign of life. What's exciting is that our suggestion is doable, and may lead to the historic discovery of an extraterrestrial biosphere in the not-too-distant future, co-author David Catling, a UW professor of Earth and Space Sciences, said in the statement. A non-biological process would produce methane and carbon dioxide, which represent two extremes of oxidation, as well as carbon monoxide, as an intermediary between the two extremes. But if microbial life were present, it would eat away the carbon monoxide, leaving behind only the other two molecules. Life that makes methane uses a simple metabolism, is ubiquitous and has been around through much of Earth's history. It's an easy thing to do, so it's potentially more common than oxygen-producing life. This is definitely something we should be looking for as new telescopes come. Chrysansontartan said. Stephanie Olson, at the University of California, Riverside, was also a co-author on the study, which appeared as an open access paper titled Disequilibrium Biosignatures over Earth History and Implications for Detecting Exoplanet Life.